Start by understanding what regression analysis actually is. In simple terms, regression analysis is a statistical method used to examine the relationship between two or more variables. Imagine you want to know how the amount of time you study affects your exam scores. Regression helps you find out if there's a connection, and how strong that connection is. It's widely used in business, science, and everyday decision-making to predict outcomes and make informed choices. By the end of this video, you'll see just how approachable regression analysis can be, even if you're not a math expert. Why do people use regression analysis? The main reason is to make predictions. For example, businesses might want to forecast sales based on advertising spend, or scientists might predict plant growth based on sunlight hours. Regression helps us understand which factors matter most and how they influence the outcome. It's like having a crystal ball, but one that's powered by data and logic. With regression, you can make smarter decisions and back them up with evidence, not just guesses. Before we dive deeper, let's clarify a few key terms. The dependent variable is what you're trying to predict, like exam scores. The independent variable is what you think influences it, such as hours studied. In regression, we look for patterns between these variables. The regression line is a straight line that best fits the data points, showing the general trend. Understanding these terms will make the rest of the process much clearer and less intimidating. There are different types of regression, but the most common is linear regression. This is used when the relationship between variables looks like a straight line. There's also multiple regression, which involves more than one independent variable. For example, predicting house prices based on size, location, and age. Each type has its own uses, but the basic idea remains the same: finding relationships and making predictions. How does regression analysis actually work? First, you collect data for your variables. Then you plot the data on a graph to see if there's a pattern. The regression method calculates the best fitting line through the data points. This line helps you predict future values. The closer the data points are to the line, the stronger the relationship. If the points are scattered, the relationship is weaker. It's a visual and mathematical way to understand connections in your data. Once you have your regression line, it's time to interpret the results. The slope of the line tells you how much the dependent variable changes for each unit increase in the independent variable. The intercept shows where the line crosses the y-axis. You'll also see a value called r-squared, which tells you how well the line fits the data. A higher r-squared means a better fit. These results help you understand and explain the relationship between your variable. Regression analysis is powerful, but it's not foolproof. One common mistake is confusing correlation with causation. Just because two variables move together doesn't mean one causes the other. Outliers or unusual data points can also distort your results. It's important to check your data carefully and not jump to conclusions. By being aware of these pitfalls, you can use regression analysis more effectively and avoid common errors. Let's look at a real-life example to make things clearer. Suppose a coffee shop owner wants to predict daily sales based on the number of customers. By collecting data over several weeks and running a regression analysis, they can see if more customers really do lead to higher sales and by how much. This helps the owner make better staffing and inventory decisions, all thanks to simple regression analysis. Wrap up: regression analysis is a straightforward yet powerful tool for understanding relationships between variables and making predictions. By learning the basics, like key terms, types, and how to interpret results, you can apply regression in many areas of life and work. Remember to watch out for common mistakes and always let the data guide your decisions. With a little practice, regression analysis can become a valuable part of your problem-solving toolkit.